Okay, today we want to talk about probability with permutations and combinations. All right, we want to talk about a sample space. That's going to be your total number of outcomes. So if you're talking about tossing a coin twice, you could get heads um, the first time and you could get tails the first time. And then, so you could get heads and heads, or you could get heads and tails. And if you got tails the first time, you could get tails and heads and tails and tails. Okay, if you want to talk about the fundamental counting principle, and trust me, you do, because you don't want to list these every time. You want to be able to figure out a mathematical way to do this. So the way to do it is it's called the fundamental counting principle, and you multiply the number of possible outcomes. Okay, so for instance, when we talked about these four outcomes, the first time you tossed the coin, you had two possible outcomes. The second time you had two possible outcomes. So you take those numbers and you multiply them together and you get there's four possible outcomes. Because it's a rarity that we actually have to know the possible outcomes. We just want to know what's the probability of a certain outcome happening. So the next thing we want to talk about, which is half of the lesson, is a permutation. And this is where an arrangement of objects have to be in order. Order is important. So for instance, if you were choosing friends and you were choosing them in a certain order, maybe to take a picture, then the first friend you chose, you would have four possible outcomes. But the second time you chose, you would only have three friends left. The third time you chose, you would only have two. And of course, the fourth friend would be the last one to be chosen. Okay, so to find the sample space or the permutation, you just do 4 times 3 times 2 times 1. Well, this is actually has a name and it leads us into our next definition, which is called a factorial. A factorial is when you multiply the number you're talking about, it's the product of the number you're talking about, 4, times all of the numbers that are less than that number n. Okay, so a factorial from D3 would be 4 factorial, which is 4 times 3 times 2 times 1, which is 24. Okay, um, so in example 1, we've got two people that want to be members of the lacrosse team. And if the girls on the team are each assigned a jersey from 1 to 20 at random, what is the probability that Chandra's jersey number will be 1 and Renee's jersey will be number 2? So the chances of Chandra getting a number 1 is 20 possible outcomes, and then the chances of Renee getting number 2 is 19 possible outcomes um, because the number 1 has already been taken. So if you're thinking about it that way, you had 20 jerseys and then one was gone, so you had 19 jerseys. So if you use the fundamental counting principle, it says to just do 20 times 19, which gives us 380. Therefore, the probability that Chandra will get the first jersey and Renee's going to get one with 2 on it is 1 out of 380 chances, because there was only one chance of 380 that this would happen. Okay, so seems pretty easy. So let's try another example. This is your example. If we've got 4 people that are trying to get positioned to take a photo, and there are 4 choices you can choose from. Um, what is the probability that Troy will be chosen to stand on the far left and Devin on the far right for the photo? Now that means you're placing 2 different people. So if you want to talk about the probability of Troy on the left and Devin on the right, and that means you already have some people positioned. So let's talk about that. That's going to be 1 out of, there's actually 4 to choose from to get for the very first choice. And then when you get to the second choice, because you want Devin to be last, you only have 2 people to choose from, then 1, then 1. So your answer here is 1 out of 8. There's 1 out of 8 chances that that combination will happen. Okay, so we move on down and we talk about, in the above example, what if we move it up from 4 people to 6 people? Now we're getting into a permutation where this is how it's noted, where it's 6 people, but you're only going to choose 4 because the photographer only wants 4 people in the picture. So the first time you choose, you have 6 choices. The second time you choose, you have 5. The third choice, you have 4. And the fourth choice, you only have 3 people left. Okay? So therefore, to do this permutation, you do 6 times 5 times 4 times 3, and it gives you 360. So the probability of choosing this, or this happening, is going to be 1 out of 360. But there is a formula that also works for permutation, where n is the number of objects and r represents the number that you're going to take out of that group. So the number of permutations for 5 objects taken 2 at a time would be 5 permutation 2, which would be 5 factorial over 5 minus 2 factorial. Okay, so that's going to be 5 factorial over 3 factorial, which is equal to 5 times 4 times 3 factorial, because it would just keep counting down. But we don't have to. We can stop there because we have a 3 factorial on the bottom. And those cancel. So you have 20 possible outcomes. But if you think about it, if you have 5 and you're only going to take 2 at a time, the first time you have a choice of 5, and the second time you have a choice of 4, which is, to me, an easier way to get your 20. Okay? Now, on example 2, we want to look at this one. And it says a class is divided into teams, and each team's made up of 15 people, and Sam and Valencia and Deshane are all on the team, but they want to be your president, vice president, and secretary in that order. So again, if we're talking about permutations, we're talking about arranging people in a certain order. So the first thing we need to do is find out what our permutation would be. So it would be 15 permutation, choosing, how many did we choose? Oh, 3. We wanted to choose 3. So it looks like this. It'll be 15 factorial over 15 minus 3 factorial, and that's a subtraction sign. So it would be 15 factorial, and a factorial does look like an exclamation point, over 12 factorial. So again, that's 15 times 14 times 13 times 12 factorial over 12 factorial. So those cancel, and then when you multiply 15 times 14 times 13, you get 2,700, excuse me there, let's fix that. Okay, you get 2,730, and that is a 3. Okay, so now we need to answer the probability. The probability of being president, vice president, and secretary is equal to 1 out of the 2,730, because probability is usually one chance of it happening out of whatever your sample space is. Okay, so looking at example 2 that you're supposed to do, you've got 4 digits. You want to choose 4 digits out of a possible 10 digits, and the digits cannot be repeated. So how many possible identification numbers are there? Well, just a little hint. You're going to have 10 permutation 4. So see if you can work that. Pause and see if you can work that. Okay, so did you get 5,040? It was 10 factorial over 10 minus 4 factorial, which is 10 factorial over 6 factorial. The factorials end up canceling. You get 5,040. The next one asks for the probability. So the probability of getting the number 4213, that one combination, is going to be 1 out of 5,040. Okay, so your next question probably is, well, Ms. Wright, what if it repeats? Like the word pool repeats the O's. And what about telephone numbers like 622-3556, which repeats 6's and 2's and 5's? Okay, so we have permutations. We have a formula for permutations that repeat. All right, so let's try example 3 using that permutation formula. All right, so in example 3, we're on a game show and we're given these letters that spell out Mississippi, but of course they're all mixed up. But um, so the probability of spelling Mississippi when the I repeats 4 times and the S repeats 4 times and the P repeats twice is you have 11 letters factorial over 4 I's that repeat factorial, 4 factorial for the S's that repeat, and 2 factorial for the P's that repeat. So if you multiply 11 factorial, you write that down, and you multiply the bottom factorials, and you write that down, and then when you divide it, you get 34,650. So of course the probability that the letters are going to spell Mississippi is 1 out of 34,650. All right, so now let's try this example yourself. So the probability, first thing we want to do is get the permutation, and then we'll get the probability. So the permutation that this is going to happen is going to be, there's 7. Actually, I'm going to pause and give you a second to work at this. Okay, so you're going to have 7 factorial over 3 factorial times 2 factorial, because your 5's repeat 3 times and your 1's repeat twice. And the 2 and the 6 are only there 1 time. So you took care of those in the 7 factorial. So it's going to be 540 divided by 12. And if you check that out, that will be 420. Okay, so the probability that you will get the number 5505211 is going to be 1 out of 420. I'm hoping that you're getting the hang of this now. Okay, so we need to talk about circular permutations real quick. This is kind of like if you put spices on a turning table, or if you got you have football players that get in a huddle, even basketball players, they get in a huddle. In a circular permutation, you can have a focus without a reference. You can have a formula, or you can have a formula for a permutation that does have a reference. So we're going to talk about both of those real quick. All right, and leave those formulas right there. All right, so in example 4, if 6 charms are on a bracelet, and just think about a bracelet laying there. If you see a bracelet lying there, then if you see a bracelet lying there, then it doesn't have a point of reference. There's nothing there to refer. You don't know what position, it's certain position that it's in. But if you want to know what is the probability that a certain arrangement can be produced, then it's just going to be 1 over 6 minus 1 factorial, because that would be without a point of reference if it's just a bracelet that's laying there. So that's 1 over 5 factorial, which ends up being 1 out of 120 chances that it would be in that position. Okay, but let's talk about another one. It says if you're seating a party of 4 people around a table, but you're talking about one person, I'm going to shortcut this, you're talking about one person that's going to sit by the window and they're going to pay the bill, then what is the probability that that person that's sitting by the window will pay the bill? So it says this is a circulation permutation, and it does have a point of reference, and your point of reference is the person that's by the window. So there are 4 factorial ways in which all the people can be seated around the table. So you have to get that to go on the bottom. It's always your sample space. How many total are on the bottom? And then if you think about it, one person's going to pay for the bill, so that person has a certain seat to sit in. So there's actually 3 factorial ways that the other 3 people can be seated. Therefore, your problem is going to be 3 factorial divided by 4 factorial, which is 6 divided by 24, which ends up being 1/4. So the probability of that one person by the window paying is 1 out of 4. Kind of makes sense, doesn't it? All right, so example 4, this one is yours. If we have a team's 11 football players huddled together before a play, what is the probability that the fullback stands to the right of the quarterback if the team huddles together at random, and explain your answer? Okay, now that the fullback stands to the right of the quarterback, this is not really a position, because the team is just huddled at random. They huddle together at random. So they don't get in a certain place. They might be there this time, they might not be there the next time. So To find this probability, we need to look back and remember, if we don't have a point of reference, our permutation is n minus 1 factorial. So if we've got 11 football players, it's going to be 11 minus 1 factorial, which is going to be 10 factorial, which is, really I'd like for you to pause right here because this is really supposed to be your problem. All the practice problems are yours, so I want you to practice this one. Okay, so when I found 10 factorial, I got 3,628,800. So the probability of this happening at random is equal to 1 out of the 3,628,800. Okay, so if a referee stands directly behind the huddle, what's the probability that the referee stands directly behind the halfback? And explain your reasoning. Now on this one, you have a point of reference. Point of reference. And your point of reference is your referee is standing in a certain position. So on this one, if you'll remember, it's just going to be n factorial, so it's going to be 11 factorial, which is equal to the 10 factorial, times 11, basically. So you come up with 3,991,6,800. So 39,916,800. So the probability of the referee standing behind the halfback, is equal to 1 out of 39,916,800. Okay? Okay, we're going to talk about a combination real quick, and that will finish us up. This is an arrangement where the objects, the order is not important. The order is not important. And here's your formula. We've been using formulas through the whole video. So here's a practice. We want 8 objects out of 3, but it's a combination 8 out of 3. It's written the same way as the permutation, but the formula is a little different. It's the permutation formula. Notice it's n factorial over n minus r factorial times r factorial. So it's still 8 over 8 minus 3 factorial, which is what we were doing for permutation. But on the bottom has to be multiplied by the 3 factorial. So it ends up being 8 over 5 factorial times 3 factorial. And watch this. So on the top it's 8 times 7 times 6 times 5, because we can cancel the 5 factorials. And then we have 3 times, we write out the 3 factorial, 3 times 2 times 1. Well, you can still cancel. You can say 3 goes into 3 once and 3 goes into 6 2 times. You could say 2 goes into 2 once and 2 goes into 2 one time. So then you have all ones left on bottom, and on top all you have left is 8 times 7, which is 56. So that would be your combination. There would only be 56 actual combinations when order doesn't matter. For instance, if it didn't matter what order you lined up in a line to leave out, to go outside. Like for a fire drill, we just need to get outside. We don't have to be in any particular order. Okay, so example 5 says, for her birthday, Monica had 6 friends out of 20 that she can invite to her theme party. It wants to know what is the probability that the friends are Tessa and Guado, Brendan, Faith, Charlotte, and Rihanna are chosen. Well, we're going to say we've got 20 friends factorial over 20 minus 6 factorial times 6 factorial, which is 20 factorial over 14 times 6 factorial. Just doing your formula, working it out. So we got 20 times 19 times 18 times 16 times 15 times 14 factorial. I know to stop there because I know those will cancel. And then I want to write out my 6 to the 1 factorial. So I want to cross cancel these. I could say 5 goes into 5 one time and 5 goes into 15 3 times. I could cancel out my 3's now. I could cancel out my 2 with my 16 and make that an 8. I could cancel my 4 with my 8 and make that a 2. I could continue because I'm almost down to all ones. I could continue to say, well, 6 goes into 6 one time, and it goes into 18 3 times. So this is what I have left. I have 20 times 19 times 3 times 2 is all that I have left. Everything else came out to ones. Okay, so your answer is going to be 2280. All right, so your probability that they were chosen, oh, it's right messed up. So let me go back and pause and work that for you one more time. Okay, let's try that one more time. The 14s cancel. Okay, we could do the 6 and the 8. 6 goes into 18 3 times, and 5 goes into 15 3 times, and 4 goes into 16 4 times, and these 3's can cancel, and this 2 can cancel and leave a 2 here, and so now I have 20, 19, 3, and 2. 20 times 19 times 3 times 2 is somewhere I'm messing up. So let me try it one more time. Okay, that's okay. We're going to try this one more time. We're going to try it a different way. The 14s definitely cancel. We were right there. The 2 can cancel with the 16 and leave us an 8. The 4 and the 5 multiply together to get 20, so we can cancel that. And the 3 and the 6 multiply together to give us 18, so we can cancel that. So we have, I see where I'm missing it. Miss Wright left out her 17. So that's where it should be. That's where I kept messing up. All right, so I've left out a 17 here, so please add it back in. So your problem now is 19 times 17 times 8 times 15. And this answer will be 38,760. And of course, the probability of that happening then is 1 out of 38,760. So this is the last thing we're going to talk about. So here is one for you to practice. I want you to pause and try this one. It works the same way as that did. Just don't leave anything out like I did. Thank you. Okay, let's see if you got this much. It should be a combination of 8 items, 8 points, choose 3. Should be 8 factorial over 8 minus 3 factorial, 3 factorial. And so 8 factorial over 5 factorial times 3 factorial. So 8 times 7 times 6 times 5 factorial over 5 factorial times 3 times 2 times 1. The 5 factorials cancel. The 3 can cancel with the 6 and leave a 2, and this 2 can cancel because 3 times 2 is 6, which leaves you 8 times 7, which is 56. So the probability of this happening is 1 out of 56, and the lesson is yours.